quiet revolution is about to make a lot of noise, and it might just flip the aviation industry upside down. Airbus, in partnership with CFM International, is developing a radical new type of jet engine, the open rotor engine. This isn't science fiction. It's a real project with real test plans already in motion. And here's the headline. It could reduce fuel burn by 20% or more. That's a massive leap. Not just in savings, but in environmental performance. In an industry where airlines measure success by the gram of fuel, this changes everything. So why does this spell trouble for Boeing? Because Boeing is sticking with conventional engines for now. And if Airbus gets this new tech flying, and flying reliably, it could leave Boeing behind in the most important race of the next decade, the race to build cleaner, cheaper, and smarter planes. In this video, we'll break down exactly how Airbus's open rotor engine works, what the RISE program is aiming for, and why this tech could be the most disruptive thing in aviation since the jet age began. The open rotor engine explained. To understand the impact of this engine, we first need to understand what makes it so different. Traditional jet engines, the kind you see on a Boeing or an Airbus today, use a turbofan design. That means there's a big fan at the front that pulls air in, and the engine burns fuel to spin turbines that push the plane forward. It's efficient, powerful, and proven, but it has limits. An open rotor engine removes the casing around the fan blades. Imagine a jet engine with giant exposed propellers at the back. That's basically what an open rotor looks like. Instead of pushing air through a tube, it pushes air directly with large blades that aren't enclosed. Why does that matter? Because it reduces drag and allows more bypass air to flow around the engine, rather than through it. The more air that bypasses the engine core, the more efficient the engine becomes. This is called a high bypass ratio, and open rotor engines have the highest of all. Early test results suggest that this design could use 20 to 30% less fuel than today's best turbofan engines. That's not a small improvement. It's a leap forward in a time when aviation is under pressure to cut both emissions and operating costs. There's also less need for exotic materials or extreme temperatures, which could make these engines cheaper to maintain over time. So why haven't we seen open rotor engines before? Mainly because they've always had issues with noise and vibration. Passengers don't want to sit next to a loud spinning blade, and engineers have struggled to make them quiet and stable. But now, with new materials, better design software, and advanced acoustic technology, those problems may finally be solved. If they are, this engine won't just be efficient, it'll be ready for commercial flight. Airbus and CFM's RISE program. The name of the project driving this revolution is RISE, short for Revolutionary Innovation for Sustainable Engines. It's a joint venture between Airbus and CFM International, which itself is a partnership between General Electric, based in the United States, and Safran, based in France. That means this is a global effort, combining decades of expertise from both American and European aviation powerhouses. The RISE program was officially launched in 2021 with one big goal: create an engine that delivers 20% better fuel efficiency compared to the current top-performing turbofans, like the LEAP engines, which power aircraft like the Airbus A320neo and the Boeing 737 MAX. But the RISE program isn't just about fuel, it's about decarbonizing aviation. The engine is being designed to run on sustainable aviation fuels, also known as SAF, and possibly even future fuels like hydrogen. That makes it a key part of the push toward net zero emissions in commercial flight. The plan is to test the open rotor engine in flight by the middle of the 2020s, using a modified Airbus A380 as the testbed. If successful, this technology could power the next generation of narrow-body aircraft by the early 2030s. That timeline matters. Right now, both Airbus and Boeing are looking at what comes after the current A320 and 737 families. Whoever builds the better next-gen aircraft could dominate the skies for the next 20 to 30 years. With the RISE program, Airbus is signaling that it's ready to lead that charge, with an engine that doesn't just tweak the old model but reinvents it entirely. And if they succeed, the skies might never look the same again. Potential impact on Boeing. So how could this engine destroy Boeing's competitive edge? To put it simply, Airbus is innovating, and Boeing is catching up. Right now, Boeing's best-selling aircraft is the 737 MAX, a narrow-body jet powered by the LEAP engine, also built by CFM International. It's efficient, but it's also based on an airframe that first flew in the 1960s. Airbus, on the other hand, is already flying the A320neo, And now it's looking ahead to something far more advanced, an open rotor aircraft with a 20% fuel advantage. If the RISE program delivers what it promises, and Airbus integrates that engine into a brand new airframe, the result could be a jet that costs less to operate, emits less carbon, and flies longer routes more efficiently. That's a problem for Boeing, especially in markets where fuel costs and environmental regulations are putting pressure on airlines to modernize their fleets quickly. But there's another angle: public image. Right now, Boeing is still rebuilding its reputation after the grounding of the 737 MAX. While Airbus is promoting future-forward technology, Boeing is still seen by some as playing defense, reacting to the market instead of shaping it. Airlines want aircraft that are cost-effective and future-proof. If Airbus can deliver a clean-sheet design with this new engine, especially before Boeing can respond, it could steal key customers, especially in Europe, Asia, and even North America. And that's where the real threat lies. It's not just about performance, it's about timing. Airbus is moving fast with a new idea. Boeing, for now, seems stuck with the old one. Challenges and considerations. Of course, no breakthrough comes without its own turbulence. The open rotor engine isn't guaranteed to succeed, and there are some real challenges that Airbus and CFM International will need to overcome. The biggest one? Noise. Open rotor engines are louder than traditional turbofans. That's because the spinning blades are exposed and they move a lot more air in the open. Even with new designs, acoustic shielding, and blade shaping, the sound could still be an issue, especially near airports with strict noise regulations. Passenger perception is another concern. Exposed spinning blades at the back of the plane could look unsafe or unusual to travelers who are used to fully enclosed engines. Even if the tech is perfectly safe, convincing the public is another story. Then there's certification. This engine is unlike anything flying on modern commercial aircraft. That means it will face extra scrutiny from aviation regulators, including the Federal Aviation Administration in the United States and EASA, the European Union Aviation Safety Agency. Getting through that red tape could delay commercial use by years. Airports and ground crews may also need to adapt. The open rotor design could require changes in maintenance procedures, runway safety zones, and engine placement, especially if it's mounted at the rear of the aircraft. And finally, there's the cost. While the engine could save fuel in the long run, developing it and building an entirely new airframe around it will cost billions of dollars. Airbus will need strong airline interest and government support to keep the project financially viable. So yes, this engine could revolutionize air travel, but only if Airbus can convince the world that the benefits outweigh the noise, cost, and risk. The future of air travel. The open rotor engine isn't just a bold idea, it's a bold challenge to the status quo. With the RISE program, Airbus and CFM International are betting big on a future where planes are cleaner, quieter, and radically more efficient. They're pushing boundaries at a time when the aviation world needs new answers, fast. And that's why Boeing should be worried, because this isn't about flashy tech. It's about solving real problems: fuel costs, emissions, sustainability. If Airbus can deliver a working, certified open rotor aircraft by the early 2030s, it could dominate the next generation of air travel. Boeing will need to respond and soon, or risk falling behind in a race that's no longer just about speed, but about survival in a greener world. So when we say this engine could destroy Boeing's edge, we're not exaggerating. It's a warning. The future of flight is being built right now, and Airbus just turned the engines on.